All right. So thank you for the introduction, Mark. About myself, yeah, I've been in IT roles, management roles at different retailers. I joined DesignMind in 2017, and I really just specialized in BI and data warehousing. Throughout my career, it was always the area that got the most accolades, and that's what I chose to specialize in. Since I've been at DesignMind, yeah, I've been at projects with Biggie Crane, Biorad, Ollie. They make vitamin gummies. Optimal Plus, which was a custom Power BI visualization project that was fun. Mazzetta Foods in the Bay Area, and Treasury Wine Estates in the Bay Area. All right, so maybe the most important slide to me. I've been a windsurfer for 37 years, learned when I was 10. I recently got into wing foiling, and I also ride the one wheel, which is this thing on the left. It's kind of a one wheel electric skateboard. What I would say is it's interesting being a beginner at things, and just like picking up new technologies, for me, wing foiling is very much like that. It's a relatively new sport. All right, so today's talk is about Azure technologies, and I'm going to start out by just describing kind of an overview of some legacy warehousing issues and something that's addressed with modern data warehousing. So it's kind of a mix of introducing data lake, which you may not have worked with before, as well as just the end-to-end Azure stack for doing a warehousing project. So I'll preface this by saying I spent about 2 days on the deck. This is my first time presenting the information. Might get better over time, but I'm going to try and in an hour and a half walk you through a lot of different technologies, point out some areas of learning for me, and some important things to know. So I've done a few data lake projects now, and what I describe in this slide is how historically, if you have different source systems, maybe SQL Server, you've got files, you have data you're getting from web APIs. The challenge is always, where do you land that data? You want to land the data somewhere so that you can work with it, transform it, shape it. And really the new way of doing that is to land everything in a data lake. If you're not familiar with a data lake is it's a cloud offering from Microsoft. If you go under Azure and you add a resource, the resource is called storage, and there's a couple different flavors of it. Essentially, it's like an online file system. The highest level is a container. You set permissions, things like that, at the container level. And then permissions are inherited downward, down to folders and files. And there's really kind of an art and a lot of best practices around how to structure your data lake. You know, when nobody tells you how you should set up your folder structure for your personal files, right? Everyone's got their own conventions, but with data lake projects, you do need to put some thought into it and have some standards and logically separate things. But a common scenario,
James, just a comment. We see the legacy warehousing slide. Is that what you intended, or you wanted?
It is, yeah.
Okay, great.
Yeah. So in this slide, I mentioned some suboptimal things. So historically, we might have read data to SQL staging tables. So this is called schema on write. So it's like we predefine where we're landing data to. That might be information from files. It might be the results of a web call in JSON that we then transform and store in SQL staging tables. The problem with that is that it's incredibly tedious. So I have tedious, rigid mapping of fields. And also a limitation is it's like this is a breaking point, right? We had a client that had solar panels and windmills and thousands of devices that were reporting information from hundreds of vendors, and they're always changing their data spec, right? It's very important that we always landed and collected the data first, and then worry about how we're going to consume it later. So the modern approach is landing in data in a data lake, right? So you have your source connection, and then you've got a folder path scheme, and you're reading information, landing it in the lake. The tool for using that is, or for performing that task, is Azure Data Factory through things called pipelines. So Azure Data Factory is one of the cloud-based tools. For transforming the data, shaping it the way you want, and landing it in SQL tables, there's another Azure product called Databricks, which I'm going to talk through. And then once the data is transformed and cleaned up, we store that in a container or a top-level folder called curated. Underneath curated would be a folder for each model object. So you might have a customer folder, a date folder, a vendor folder, a customer invoice folder, and then beneath those folders are files. Right, the data lake is a folder and file structure. And then we populate SQL stage tables, we post to model tables. So let's get into the Azure, or the process and how Azure fits in. So from 1 to 5, this is what we all do in warehousing projects. We ingest and store information, we prep and store information, we model and store information, we provide some kind of semantic or analysis layer, and then we have our presentation tools, right? So these are the 5 things that we do. I call this like the data refinement process. But what we're going to do is take a look at, well, how do you map Azure technologies to this process now, using all cloud-based technologies. All right, so this is the same slide, but what I've done is I've listed some of the technologies below. You see a common thread across all these is Azure Data Factory. The real heavy lifting that Data Factory does well is reading data from a source and to a target. So you can think of SSIS as serving that function. You know, this is like a kind of a cloud alternative to SSIS in that respect. It supports hundreds of data sources, and it's very efficient and scalable at moving data through what's called a pipeline from source to target. So what I have here is extracting data to data lake as its primary goal. So you have your data source connections, your copy activities, and you're going to land data into a raw container. And you might want to write your own kind of auditing for this process. I typically do that. The second step is involves Azure Data Factory, and this is from an orchestration standpoint. So at this point in the architecture that I'm walking you through, Databricks is the tool that's going to do all your data transformation. Databricks has a construct called notebooks, and notebooks are logical containers of code. That code could be Python, R, this language called Scala, but really it's the Spark data platform, which is an established platform that Microsoft has wrapped and built some GUIs around and some features around, and offering it as Databricks. But it's a well documented platform. So inside these notebooks is where you're going to transform data, and you're going to land it this time in a data lake in a container called curated, right? So we've got our source systems that Data Factory is pulling data from, landing it in the data lake in a raw container. Databricks takes over, reads data from the raw container and folders and files, transforms, shapes the data, stores the model data back in data lake into this curated container. Prep and store. So really there's a couple of things that can go on here. I don't want to oversimplify things, but In the case of raw, ideally what you'd be doing is pulling down incremental changes only to raw. So imagine you have a directory that has like lots of files and only incremental changes in each file. You're going to have to construct what the current version.
We can hear you.
All right. So apologies about that. My internet seemed to have dropped on my end. All right. So picking up where we were, Azure Data Factory is orchestrating this process. So that Data Factory is calling Databricks Notebook. Databricks Notebook's performing work, things like that. All right. So getting started with Azure. If you don't have an Azure environment, the hierarchy of things you'll need is you'll need a tenant, you'll need a subscription, and those are the two main things. From then, your first decision or your first act is going to be creating what's called a resource group. So typically, a resource group is a container of Azure resources. So what I typically do is I have some naming conventions that I use on every project. So I'll use RG dash the customer name dash dev. These resources, because it's a cloud technology, the names have to be unique in the world. Yeah, so you can't just call resource group development. That won't be available. So I found success with this RG dash customer name and then dash dev for development. The benefits of Azure, all these tools that I'm going to show you talk to each other. They all support Active Directory, authentication, and like access control. One of the things with this, with all of these technologies, is are these ideas of like security principles. So a lot of times, let's say that like Data Factory needs to access your data lake. You'll browse Active Directory. Instead of a user group or a user, you'll actually select the Data Factory resource, which is an identity. They call it like a managed identity, and you'll grant permission to one of these Azure resources. And there's actually a lot of steps involved with that to get these to all talk well, and that very well may be a follow-up talk. So this slide is to get you visually thinking about what tools you're going to work with, right? These are the icons I pulled from Azure when you create a resource. So I started a new project last week with a client, and I literally spent my first 2 days spinning up each of these resources, going through configuring security so they all talk with each other. So this was all very top of mind for me. But you're going to spin up an Azure Data Factory resource, a data lake, storage resource, a Databricks resource, SQL resource, and analysis services. I have a bit at the end of the talk on analysis services, why I still prefer this to host models over Power BI. I have a slide on that. But yeah, and then there's a few other things here. So there's something called app registrations. If you've never heard this term, I've thought a lot about whether registrations is really the best word for this. It's really like an application security principle. So a common question is like, okay, in my code, I have to connect to a resource. I don't want to use my own name, right? Or a username. So a lot of times people will create, like historically, will create like they'll call it a service account. This is like an account in Active Directory that, they disable a password expiring, and they do all these kinds of things to use it as a way of connecting to things. So Azure doesn't do it that way. Instead, there's this thing called an app registration, and it has its own ID and it has a token. And then you grant permissions to things, or grant that app registration permission to things. So let's say I create an app registration, and my intent is I want to access information on Data Lake. Well, I might permission my container with that app registration. Then in Data Factory, when I make my connection to Data Lake, what am I connecting with? I'm connecting with my app registration ID and, you know, credential. So that's app registration. It's a key part of this architecture. Another thing you might not have heard of is called Azure Key Vault. Now, Key Vault is a kind of what it sounds like. It's a mechanism for storing connection strings or server names or usernames, passwords. And there's a lot of areas in Azure Tools where, especially in Data Factory, when you're making a linked service connection or you're connecting to another data source, there'll be a slider. Like you can either enter in the credentials manually, or you can change the slider to pull them from Key Vault, and then you specify the name in the Key Vault that you want to pull the value for, and that's how that works. So Key Vault's important. These other two, I call them like optional Azure resources. It really, it really depends on the project. Let me back up a bit. It really depends on the project. So Data Factory does, you know, again, think of it as like a cloud version of SSIS, right? It can do a lot of things, but there's certain limits that you'll hit with it, right? So I'm on a project now where I had to connect to SharePoint. I had to iterate through a bunch of folders and download files to Data Lake. Not really possible with Data Factory, but you can do it easily with an Azure Logic App. So Azure Logic Apps are for building complex data flows, you know, where there's a data connection, a bunch of steps you need to perform, and then an output somewhere or an event that you want to trigger. It's a very flexible system. I would say it's sometimes hard to get your head around like where all this stuff fits in. There's like Power BI data flows. Data Factory has a new area called data flows, and they have Power BI workflows, I think they're called, and there's Azure Logic Apps. It's kind of hard to say which is like the best one or which one is going to have the longest life, but Logic Apps has been around for a while, and is a really, really cool technology. Where it fits in is Data Factory can call a Logic app and pass it parameters and then receive the output, right? Azure Functions. Azure Functions are interesting. Basically, it's a type of app. So you go under Azure and you say create a new resource. What kind of resource? An Azure Function App. And basically, it's a serverless environment for hosting functions. And those functions can be written, when you create an app, you have to choose a runtime. So your runtime can be .NET. If you choose the .NET runtime, then you can create a Visual Studio class library that has all the functions that you want to expose. From Visual Studio, you publish it up to this Azure Function App, and now you can do things that you might not be able to do with Data Factory, right? But you could easily do in C# kind of thing. So this is the whole stack, right? I said most of this, but this is just a slide kind of reiterating it. Secure Key Vault, secure storage of secrets. And in this architecture, I'm pretty much just using Key Vault for Data Factory. There is a need in Databricks to store connection credentials securely, but Databricks happens to provide its own mechanism for that. They have something called scopes and secrets, and I opted to use that instead of Key Vault. Although I think you can get Databricks in code to talk to Key Vault, but wasn't as well documented. All right, so Data Factory we talked about. It's data ingestion and process orchestration. Right, there's always this argument about what do you do with SSIS, and some people loved it historically for 20 years to go wild building elaborate ETL. Other people chose to build elaborate orchestration and do the transformation either in SQL or some other tool. Same kind of decision process with Data Factory, how you're going to use it. There is an area called data flows, and just like with SSIS, like it's GUI based, you drag and drop things together, but then you hit a limit and it's like there's something you can't do, and then it's like, oh, now what? Am I going to have this one-off thing that I solve somewhere else, but my other design patterns use this? You start to hit those points, and with Databricks, you don't hit those points. So Data Factory gives you like a GUI-based data transformation area. Databricks is more code-based, right? So depending on the skill set in your environment and your appetite for this kind of thing, that might affect what technology you choose or which path you take. I'm walking through a framework that uses Databricks. All right, storage. So I don't know if I mentioned this or not, but 20 years ago, I was at a company where we spent $1 million on NetApp's NAS storage, right? And it was all this research. Do we go with EMC? Do we go with this? And it's so amazing that 20 years later, storage is so accessible, limitless, inexpensive. So this is just a brave new world, the data lake thing. Very inexpensive. You don't need to worry about cost with data lake. There are things like hot and cold environments, right? Like it's cheaper to store stuff in cold storage. I'm not familiar with them, but I'm sure there's products that roll off data from hot to cold to save you money and things like that. But talked about Databricks.
By the way, James, there's a question from Venkatesh. How does it handle data that is arriving out of sequence?
How does which product?
Yeah, Venkatesh, he just posted at 7:32, so about a minute and a half ago.
Okay.
Data Factory clarified.
Yeah.
ADF.
So Data Factory is like these pipelines. These pipelines get executed like on a trigger. They're not listening in per se on events. So it's not a streaming type of data ingestion. That can be achieved with other products. I think it can be achieved with Databricks, to be honest, although I haven't done it. So assuming you're talking about streaming data, like where you need to be listening in for new data, that's not part of this talk. This is more traditional, traditional warehousing, where on a schedule, you're going out and you're pulling data from different sources, and the tools to use them, and the different design paradigms and things that you have to consider. Okay, SQL Analysis Services, we're familiar with those. I mentioned about Logic Apps and Function Apps. These are cool things to play around with. All right, Key Vault. What do I put in here? Again, these are your connection strings, resource paths, server names. One thing that you might not realize about storing things like this in Key Vault is, at a basic level, they're like name value pairs, right? So like I'll call it like SQL user or SQL password, right? And then there's the value is what the secret is that gets stored. Bigger picture, you're going to have a data factory, an elaborate data factory environment that connects to a lot of different data sources. You're going to have that in a development environment, and then you're going to publish that to a production environment, right? And the beauty of storing everything in Key Vault is in your production environment, you just specify a different Key Vault to connect to, right? So I have a Key Vault in dev, a Key Vault in production, and provided I've named all my secrets the same way, all of my code is going to work, right? So there's no embedding of things in applications, and makes moving code in between environments easier. And then also just it's bad practice to store. I didn't mention this about ADF, but everything in ADF is stored pretty much in JSON files. Like you have a nice GUI for working with data, but in the back end, it's storing everything in a JSON file. In the back end, it's connected with GitHub. So like, if you're typing in credentials and things like that, that will actually end up in your source code repository, which might have a much broader audience, and you may not want that. So Key Vault, important technology. I have some things that some information here that I'm just going to kind of gloss over really quickly. It's a little too much detail, but and it has to do more with security and things that'll probably be part of a separate talk. But there's authentication and authorization to Key Vault. There's something called a Key Vault secret user role, and for this you have to grant your Data Factory make it a member of this role. And then in addition, there are these things called access policies, and there's a key and secret management policy, and you'll need to grant your Data Factory that as well, which authorizes it to read secrets. The whole security stuff around all of this to work, it can be pretty tricky, and it took a while for me to get my head around. A second or third time around, though, I'm totally comfortable with it. All right, yeah, and then these are the attributes of secrets: name, value. They can have an activation date or an expiration date. You can enable or disable them. Vault. All right. So what is Azure Data Factory? Again, some of this might sound repetitive, and I apologize. I'll gloss over the stuff I think that is repetitive, but again, I just wanted to drive home what it is in this architecture. It's about data source connections. In Data Factory, those are called linked services. It's about pipelines. It's about extracting data from source systems and landing it to the data lake. And then after that, it's about orchestrating processing. So whether that's like calling Databricks notebooks. In my projects, I have like a pattern where I have like a control table where I have like a table that contains all the list of entities that I want to process. And then based on some dynamic names, I might iterate through that, and I might call Databricks notebooks. I might call a SQL Server stored procedure. I might do a bunch of things that follow the same name pattern, right? But all that orchestration is done with Data Factory. Data Factory has great monitoring. It has great debugging. If you've never worked in there, it has tremendous debugging. Probably, I think one of the aside from Visual Studio, it's like probably one of the most elaborate debugging I've seen. All right, yeah, wide range of data sources supported, intuitive debugging, integrates with source control. That's an important point. Actually, one of the last slides in my deck is on how to set up your all of these technologies to work with Git. It's a beautiful set of slides that is worth sticking around this talk for to see. All right. Yeah, I'm gonna skip over this slide about configuring Data Factory. Here's a bit just on what the workflow is. Like if you provision Data Factory and you were going to get started with work, the first thing you're going to do is create your linked services, right? These are the data sources you're going to connect to. The second thing, which is not so obvious, are creating what are called data sets. A data set really is like a definition. What is it? It's a it defines, in here in the description I say it's a view of data that points or references the data you want to use. I'll give you an example. Like if you're connecting to SQL Server, you'll have a SQL data set. Now, a lot of people think that you need to create a data. Let's say I'm connecting to 10 different SQL Server tables. You don't need to create 10 SQL data sets. I would think, I haven't seen this personally, but I would think that that was maybe a common mistake. It was certainly my first instinct when I was using the tool. And I was a little put off by how tedious I thought things were going to become. You don't need to define a schema. And this is true whether you're connecting to SQL. This is true if you're connecting to like Excel. like really any data source, you have the ability to specify a schema, but in many cases you don't have to, right? And that provides you the ability to reuse the same data set over and over again for different purposes. All right, so you connect to the data source, you describe what the data, you need a data set for the source and a data set for the target, I should mention. And then you have a pipeline, and the pipeline is what does the work, moving the data. Another component is called a trigger. A trigger is what executes a pipeline or a series of pipelines. I should mention that pipelines can call other pipelines. You can organize pipelines into folders, right? So like since Data Factory is used for, I'm saying to use for orchestration of your end-to-end ETL, I create a folder, I number them at the beginning of the folder, 0, 1, 2, 3, 4, so that they sort properly, and then I provide a description. And then I usually have a parent pipeline, and that parent pipeline might execute a bunch of sub pipelines. That's how I do it. And always when building a pipeline, I always try to think of it as like, how generic can I make this, right? Like if my goal is to read information from SQL Server and land it to a folder in Data Lake, I'm not going to build a pipeline for each SQL Server table I'm going to connect to. I'm going to build one. For that type of activity, I'm going to leverage parameters, right? And a parameter might be the SQL Server table name, right? On my SQL data set, and then on my ADLS data set on the other side of the pipeline, I might specify a directory and a file name, right, as parameters. So these data sets can be parameterized. Data sets can be parameterized, pipelines can be parameterized. And I highly recommend that so that you're not creating excessive amounts of objects in Data Factory. You want reusability. All right. Okay. Yeah, so this is just a little bit of a preview. I think I have a slide after this too. No, okay. A little later on, I have another view of this subject, but what does it mean to land data in a data lake? Like, what does it actually look like, and how do you structure it? That's pretty much like a whole separate talk. So I'm just going to, just at a high level, talk about one scenario, which is landing data into raw. So I mentioned that raw would be a container. That's your top level container. Obviously, you're going to be pulling data from different systems, right? So how do you organize your folder structure, right? So, and this is just a recommendation. You can Google this subject and probably find something similar. But what I like to do is I like to have a folder for each source system, right? So if I'm connecting to Microsoft Dynamics, and then another connection is to SharePoint, another connection is to some weather API. Those are different. Those are examples of 3 different source systems. Then I like to have a folder called data, where I'm going to land everything. Now, in the example of Excel files from SharePoint, I'm actually, with this most recent project, I have source system, which is SharePoint. I have a subfolder called blob, and then I have another folder under SharePoint called data. Data is my working, this is my like JSON, this is my JSON file that has the data that I want. Blob is going to be whatever I pulled down. It's kind of like another layer of transformation, but I won't kind of distract you with that. So the point is that, yeah, under your raw folder, I recommend having like a hierarchy of source system, data, and then entity. So entity might be like, this would be a SQL Server table name, or this might be like a specific web result, or some like data response that you're getting from a web service, right? But just some term to describe what it is. And then there's this idea of like, and you might have seen this, like where you've got a year folder, a month folder, day folder. So that folder structure of year, month, day means different things based on what container you're in, right? Or at least it can mean whatever you want, but the way I do it is when I'm looking in the raw container, and I have things split up into folders this way, those are extraction dates. So those are days that I pulled down data. And below this, in the file name, right? So in that directory, I construct my file name, right? And this is all done in Data Factory with like variables, things like that. You construct the file name that's got your source system, your entity, and then the date it was pulled. The reason for that is like I could copy this file and paste it on my desktop, and I know exactly what it is, right? It's beneficial to have some structure in your names. But essentially, you're landing data this way. When we talk about Databricks, I'm going to talk about. When we talk about ADLS, I'm going to talk about file formats. This example is showing JSON, but you can land data in Data Lake in like 4 or 5 different formats.
So James, you just answered one of the questions, the one from Dan Hess.
Okay.
He's asking about different file formats supported, and so you hit on that. And then Diego Chapman is asking if does it handle incremental loads, and I think you're going to cover that as well. Go ahead.
Yeah. So I can chat about that real quick. I don't have a slide specifically on incremental loads, but what I can tell you is in solving that, well, first of all, you need to know whether your data source is conducive to incremental loads, right? For instance, like if you have a source SQL Server table and it doesn't have a primary key, it doesn't have a modified date, you're going to have a hard time pulling incremental changes, right? Assuming you have a primary key and a modified date, then you, as part of your Data Factory implementation, I typically have a SQL database and I create a schema called control, and then in that control schema I have some tables like configuration tables, right? So you might want to have if it's SQL Server that's a source, you might want to have like a config table that has all the table names, and then like a watermark date column that just says, okay, this is the table, this is the last date that I pulled data. When I go to query SQL Server again, I'm going to query everything with a modified date greater than that date. So the function of incremental stuff is not a function of Data Lake per se. It's how you, as the person building Data Factory, builds it out. When you call SQL or you call your data source or your web API, are you able to pass a filter, right? Some web services have a filter, some OData things I've seen, like with Navision, like don't, and you have to do a full extract every time. It really varies, but you have to get your head around the fact that you're probably going to need some kind of control table in a database where you're storing a watermark, and you're going to have to write some logic in Data Factory to be smart about pulling down incremental changes. That's one part. The second part of it is, let's say that you had and I'll give an example of like a sales order. And let's say it was entered on January 1st, it was manipulated on, a new line was added on January 5th, and then on January 10th, a quantity was changed. You're essentially going to have 3 files that come down to your data lake, right? Well, you're going to have to just think about how you would solve it in SQL Server, right? You'd have to join all those records together, group on primary key, do a max of the last modified date, and identify what is okay, I've got 3 records that all have the same keys. Which one has the last modified date? All right, that's the winner. You have to shape the data. That process I've done in Databricks. And I actually have a generic approach to that where I pass a notebook I created, the object name, a comma separated list of keys, and the name of the modified date, and it just does what it's supposed to do. But it's not trivial. It's a good question. It's not trivial, and it's something that you'll have to develop. Yeah. All right. Data Lake. So again, a lot of these are things that after the fact you can look at and read these, but I think I've spoken to those already. Maybe a couple things in here actually. One is about the uptime. And Microsoft promises 12 nines of uptime. There's something with Data Lake that I didn't mention, and that is the redundancy of it. And you have a choice when you're creating your storage, whether you do locally redundant storage, which they call LRS, or I think GRS, which is geographically redundant storage, and you can pick different zones. So if you're a company that had headquarters in Texas, California, and New York, you could set up your data lake so that in the back end, Microsoft is replicating the data to those 3 locations. Things like that. There's a, look, the cheapest and default behavior, I think, is local redundancy, and I think it keeps 3 copies in the same data center somehow. I don't know how they do it, but that's an area that you can choose, and it's another highlight of data lake storage. All right. Something else about data lake. I like using like dashes in resource names. There's 2 resources that you can't do that with, and I don't know why. But ADLS storage, everything's got to be just lowercase, and it's got to be all just continuous. So it's a really, really ugly name. That's all I can say. The other one is, I think, Azure Analysis Services is the same thing. You can't use any hyphens or underscores in your names. Don't know why. All right. What I'll mention here about data lake storage also is that there's some things that you do inside the portal, right? You can create your containers in the portal, and you can configure your role assignments. But then there's another desktop tool, Windows desktop tool called Azure Storage Explorer. And imagine it's like a Windows Explorer, for your local file system. This is like a Windows Explorer for data lake. Same thing, browsing folders, right-clicking, setting security, things like that. So yeah, that's a free tool. Last thing on data lake is there are, I forget what they call it. I think they call it data protection services or recovery services, but there are things you can enable like soft deletes and retention for deletes. People have asked me well, how do I back up everything that's there? I don't really have an answer for that other than these policies that you can set. There may be that's beyond IT infrastructure stuff for me, but there are different policies you can set. It does add a bit more cost for but you can do things like that with data lake. All right, and to that I would say you really have to think about what you would concern yourself with. I would say that anything that lands in raw, you would concern yourself with protecting. Anything downstream of that can be recreated from data in raw. That would be my 2 cents on that. Okay, I didn't mention this about data lake, but this is a super important one. And it'll become more clear in later slides. So it's this issue of, I call it data partition strategy. It's the idea of having information split across many files versus a few very large files. So let's say you have 100 million customer records. You don't want a 10 gigabyte CSV file in your data lake. It would be much better to have 1,000, 10 megabyte files. And our partition strategy, it's kind of an advanced topic, but just I'll mention how the technology works and maybe it'll help you understand. So the way Databricks works, so Databricks is the tool we're going to use to read data from data lake. Databricks has these clusters and nodes, right? There's basically potentially lots of workers that are could be reading files and then combining them together to come up with a result set, right? when you have many files, then you can have many systems doing that work very quickly and assembling a record set versus one resource, hogging like a huge file to do all the processing. I don't know a better way to describe that other than it's kind of it's a distributed system, and in general, having many small files is a better approach. So if you come across this term data partitioning, that's kind of what that's about. Your folder path convention and your file name convention, again, there's nothing out of the box that's going to just do this for you. It's an important consideration. It's important to have whatever pattern you go with to be consistent with it. So like whether you're pulling SQL Server data or web APIs or whatever you're doing, that you organize your data in your data lake the same way. And, yeah, I would say one other thing is when you're writing your, okay, we'll get to the file types. I think, yeah, here we go. Someone was asking earlier about file formats. So I have a couple screenshots here where these are taken from. So I mentioned in Data Factory, you create linked services, right? One of your linked services is going to be a connection to your data lake. The next thing I said is you need to create your data sets. So if you're pulling data from SQL, you need a SQL data set. And then if you're going to be writing to data lake, which we are, you need a data set that describes what format you're going to write to, right? So in Azure, there's lots of different storage. So when you configure a storage resource, you answer some questions. And when you answer those questions, you want to choose like generation 2, that's the most recent version. Yeah, so when you're creating your link services in Data Factory, we're going to choose Gen 2. And then these are all the choices that you have. So at a really basic level, like I had a project where we just did everything in CSV. So we had different source systems. We read everything to CSV in raw. We shaped the data, stored it in CSV and curated. And yeah, and that's the way we went. The project I'm doing now, I'm doing in using JSON. Both CSV, I guess at the end of the day, there's many considerations, and you should just Google this topic, which format. I would say generally, when you're landing data, JSON or CSV is a good format for raw. And then for curated, it really depends who the consumer is going to be of the data. If you're, yeah, so like, and how much data you have. One of these formats, I believe it's Parquet, is like a highly compressed format. So your write times, in theory, would be slower to write data out to Parquet, but reading it will be much faster. And the question is like, well, who's reading it? Is it your warehousing ETL process? Is it some like machine learning tool that you have that's going to be reading it? Is it data scientists that are using Databricks that are going to be plowing through massive amounts of data? I would say like for retailer type projects that I work on, traditional like transaction data, I haven't had a need for Parquet format, but that could easily change if I were to work on a more high volume environment. But yes, these are the file types that are supported by Microsoft's Data Lake and Data Factory. So hopefully that answers the question. All right, and by the way, one other thing on files is like some of these formats, and it might be Parquet. Some of these like store like kind of the structure of data too, right? Like CSV doesn't store structure of data. JSON doesn't store structure of data. One of these formats, it's either Avro or Parquet, I believe stores like, okay, this is a date type field, or this is a varchar 100 field, kind of thing. So data types. All right, Databricks. All right. So, by the way, hopefully this is helpful. I put this like breadcrumb thing along the top as we've been discussing topics, so that this doesn't just seem like like it's all over the place. We started out with Key Vault. We talked about Data Factory and pipelines. We just talked a bit about storage. Now we're talking about Databricks, and then we'll get into SQL and analysis services. All right, looking at the clock, we got about a half hour. All right. Okay, so again, Databricks is Microsoft's branding of the Spark data platform, or Apache Spark data platform. They tout it as an all-in-one analytics platform. And by that, think like you can do data source connections, you can do data transformations, you can also do a bit of analysis type work. It supports the R language. It generates inside notebooks. If you've never seen one, you can render data grids that you can sort. You can render charts. You can also do collaboration in Databricks, right? So what that means is that, like, if you've ever worked in a like a Google Doc, where, and I guess Office 365 does this now, like where multiple people are in a document and you kind of see everyone's cursor and what's going on. So there is that kind of collaboration that's supported in Databricks. The most basic level of Databricks does that to some degree, but then if you want to get really granular with security and who can do what, there's like a premium tier, I think they call it. Yeah, so Databricks itself introduces this concept of notebooks. Notebooks consist of, they're like containers for your code. There are different data cells, so you can execute a data cell either manually in sequence, or just run the whole notebook and it runs them sequentially, or you can just run little blocks of code if you want. Similar, I guess, to like highlighting a little bit of SQL inside a query window and just only executing that SQL. It's a little bit like that. What would I say about about notebooks? One thing you can do with notebooks is you can call other notebooks. So one of the things I do on projects is let's say I'm working with Data Lake and I'm working with SQL Server. I'll have a notebook that will have a bunch of functions I've written and that I reuse from project to project for saving records off to ADLS or reading records into a data frame. Just like things where I'm leveraging the libraries they provide, but I'm doing a bunch of tasks. Rather than repeating those same blocks of code in all my notebooks, I consolidate that into one notebook. And I just want to point out that when you run another notebook within your notebook, everything, all the variables you've defined or declared and functions and everything are available within the current notebook. It's kind of a cool thing, like kind of like an inheritance kind of thing. In Databricks notebooks, you can reference other libraries. So you can write Python code, Scala, R, and then there's all these libraries. Because the Spark platform is so widely used, like there's a library for everything that you want to do. I would say that I picked it up pretty easily. Yeah, that's what we'll say about that. And then just a quick bit, Data Factory, I'm calling it more of like a GUI-based tool for transformations, which, if you don't have that highly skilled team, you might look at going that way, but you might hit walls, and then it's like, okay, now what? No, well, now I need something more. How do I do it? And with Databricks, you lose the the GUI-based option, but it's pretty limitless what you can do transformation-wise. All right. Okay. Yeah, these configuration things are a little too detailed. All right, one thing I'm going to mention is, so maybe from the perspective of like once you have Databricks up and running, what are the first things you're going to need to do? So I did that with Data Factory. I told you you do your link services, you do your data sets, you do your pipelines, your triggers. With Databricks, there's a few initial steps that you're going to need, or you're going to want to do. And it's not, they won't tell you this. Like this is like, this is like best practice. I would start right out with scopes and secrets. So a scope is like a grouping of secrets. So a scope might, let's say you have two data sources. You have SQL Server and you have Data Lake that you're going to connect to. You might have a scope that's called SQL Server. In your SQL Server scope, you might have a secret for the database name. You might have a secret for the username. You might have a secret for the password, right? Then you might have another scope called like ADLS, and you might have your app registration ID, your app registration token. Like you'd store all of those in secrets. And then you test and make sure that you can retrieve the secrets and everything works, right? The second thing you're going to want to do in this example is you're going to want to mount your ADLS drives. So this is like one of those things where it's like, okay, I have this Azure storage and I've got a container called raw. Well, I want to read files from it from Databricks. So how do I do that? Well, you go online, you'll Google like a block of code that says, okay, this is how you do it using an app registration. So you're going to kind of take that code, template code, create your own notebook with it, and then go one step further and rather than hard coding in those credentials and stuff to connect to your storage, instead you're going to leverage the scopes and secrets that you configured. So you take that working code example you find online and you replace their values with things that you're, in practice, you'd create a variable, called like ADLS token, and that token is equal to, whatever the syntax is for reading a secret, and then you store it in the variable, and then in that pseudocode you replace it with your variable. But anyway, those are the two things: scopes and secrets, and mounting your drives. One thing about mounting drives is they're always mounted until you specifically unmount it. So you can start and stop your clusters and exit and leave the app and all this stuff, but they're always going to be available.
So James, Diego's got a question. Is Spark or Databricks only used for processing data which is already stored in a data lake? Is it possible to run any extract scrape script on it? Or should we leave those use cases to Data Factory?
Yeah, so, all right, it's a good question. The perspective I'm speaking from is this, and why I keep using these only these two examples is I'm speaking of like, from start to finish, how you would do a warehouse project. So the short answer is yes, you can connect to other things other than Data Lake, but I'm not recommending that you do that. I'm recommending that you do that kind of thing in Data Factory earlier on, right? So your ingestion of data in this architecture is done in Data Factory to Data Lake. Data Factory can connect to web APIs or any data source, right? By the time that we get to Databricks in this architecture, we're just reading from files that we've already put in Data Lake, and then we're going to write that eventually to SQL Server. But to answer your question, yeah, you can do all kinds of connections with Databricks, for sure. Okay.
I have a sample for you to see if you like it. I'll take your word for it. Agent Gibbs.
Okay. All right. So this slide is actually showing you a bit of code in Databricks and some visuals about what's going on. So in this, I've got, in my raw area, I've got like this vehicle folder. It has a bunch of files from vehicle information I pulled down. In this raw container, I've got an insurance folder. It's got a bunch of insurance records for vehicles. And basically what we do is, and this is like super simplified syntax, but in our Databricks notebook, we declare a variable for vehicle. We do spark.read, and because our source is CSV files, we do .csv, but there's a spark.read JSON and what other other types of file formats. And this is basically saying, like, I want to read all of the files from the vehicle folder, right? And I want to read them all into a data set. So this is, or a data frame, they call it. So I will have a vehicle data frame, and then I'm going to have an insurance data frame. And the beauty of Databricks is, I just have one example here. The beauty of Databricks is one of the languages it supports is SQL. So I can write a SQL statement that we're all familiar with using these objects, these data frames. So you think of a data frame as a data table, right? And like I can do group bys, min, max, window functions, like all of the things that I would do in SQL Server, I can do in Databricks without querying a database, right? So the magic here is that I'm like reading a file system, reading like lots and lots of files into data frames as if they're tables, and then working with them and shaping them that way. So here's like a query that takes information from 2 data frames and returns a result set. And I'm saying in this visual that I want to write that new result set to back to CSV, but this time I'm going to write it to a folder called curated vehicle, right? That's essentially like the kind of transformation that you can do. There's other things, like if you ever worked in C# with like link and those lambda expressions, like you can do things like that. There's a whole syntax for that where like you don't have to write SQL per se. I could do like vehicle dot inner join, and then in parentheses like insurance dot select, and and there's a whole syntax for listing my columns and stuff. You can work in that kind of manner too. I find in my projects working this way is kind of easiest for lots of reasons. Like, let's say it's like the SQL gets like really crazy and you're having a hard time debugging it and everything. Well, you can quickly load stuff into SQL tables, run this code in Management Studio, and you can debug outside of Databricks, or you can debug in Databricks, but everyone's comfort level is different, and having all your transformation logic this way makes it portable, is my point. Whereas the other syntax for data shaping, although it might be more elegant, isn't as portable. All right. This is another slide. I took this from another presentation, but this, again, it's just like visualizing like what is my data lake going to look like, right? So here I've got a stage container. Stage in this case would be my version data. I've got a folder called operations. Under that, I've got a source system. I got invoice header folder. I've got invoice header records that, in curated, or in stage rather, these represent the version date. So I'd probably only, the point is like lots of files, but then when it gets to curated, like all of these invoice header, invoice detail, invoice freight gets kind of denormalized, curated, and stored in something called customer invoice, right? The next step in this is, so what are you left with at this point? I probably should do a slide for this. What you're left with at this point is that you've got a really robust process for landing data to a raw container, right? It's kind of set it and forget it. The source data might change, New columns might be added to SQL tables. Your web API might return a different result set. They might add things, take things away. Doesn't matter. That's never going to break. You're always going to land your data in raw. You start being concerned with what that raw data looks like when you start shaping the data, or when you start coming up with your versioned version of data. And by default, you're going to want to like come up with the latest version of data, right? But like, let's say like 3 months down the road or a year down the road, someone in the business says, you know what, I want like a I want to know what our sales rep hierarchy look like, at a particular point in time. And in your warehouse, you didn't build a slowly changing dimension, and in your warehouse, you just don't have it, right? Well, because you've got all that data landed in raw historically, you have everything you need to construct a slowly changing dimension like after the fact, right? So it's kind of like this whole idea of landing data in the data lake. It might seem like it's a lot of extra steps, but the beauty of it is that your data ingestion is not fragile, and you can, because it's so cheap to store, you can land a lot more than you just start thinking about for your warehouse, right? Like your customer record might have 5 fields that you need for warehousing, but really it's got like 100 fields. So like in traditional warehousing, you just bring in the 5 fields. SQL storage is expensive. Processing is, you don't want to like process more than you need. With data lake, you don't have to have those constraints anymore. It's like bring in as much as you can. Yeah, so you're left with that the beauty of that raw container is that, yeah, you got a lot of stuff to work with there. You can version it by landing it in a container called stage. After it's versioned, you can shape that version data into something that's curated. Curated is like your model. Like if you were to sit down and come up with like a dimensional model for something, your dimension and fact tables, think of your curated folder structure as being the same thing, right? You'd have a folder with that match your dimension names and fact table names, right? All of that is in data lake. So really like other users could query the curated data lake, right? Would I build Power BI reports off of data lake? No. Yeah, it's just not gonna perform well. The read's gonna be really slow. You couldn't do a live connection to a data lake. That's hopefully obvious because you can't do live connections to file sources, right? And this is kind of like a file source. So it would have to be import mode, and it's just not ideal, right? It's not what I'm recommending in this architecture. So the next step in this architecture is our trusty Azure SQL. This can be a little confusing at first if you've never worked with Azure SQL. Now they kind of present you, because I just recently provisioned stuff. It looks like they changed the screen a bit, and they more clearly give you 3 options. You can do SQL database, SQL managed instance, or SQL virtual machine. I crossed out managed instance and virtual machine here because for our purposes, those are probably not needed. What does managed instance give you? There's somewhere online, there's like a listing that shows what it gives you. The ones that stuck out for me were cross database support. So this is where like where you have like multiple, let's say you have 2 databases and code in one database is accessing objects in another database, right? People do that sometimes. Common language runtime. This is if you've got some really specialized logic that you've written, usually C# code for, and then registered as a CLR inside SQL. Again, that's a real specific thing. Sql Agent. You lose Sql Agent, but you don't need it because you're using Data Factory. So Sql Agent is mostly used for like orchestrating and scheduling jobs. You don't need it because you're using Data Factory for that. So I kind of crossed out these 2, but those are options that are on there. Can I use my normal development query tools? Yes. So I can't stress this enough. I don't know. Hopefully everyone develops SQL Server this way using Visual Studio SQL projects. I have been for, I don't know how many years. I feel like it's been like at least, it feels like it's been 10 years. But I still come across people that don't work this way. It's such a beautiful thing. But yes, you can do Visual Studio database projects and publish to Azure databases. And I recommend that you do develop SQL that way. Integrates seamlessly with source control. Publishing is super easy. You don't need to write special deployment scripts most of the time. Just works. If you don't know, Visual Studio will do like when you publish, it'll do a schema compare between what you're publishing to and your source code in Visual Studio, and it will intelligently come up with what needs to be published to the server. And it detects dependencies. If you have a procedure that references a view, that references a table, it deploys everything in the right sequence. It's a beautiful thing. And obviously you can use Management Studio to do ad hoc queries against Azure SQL. All right, I should put this in bold up top. One of the beautiful things about, I can say this about Azure SQL, and I can say this about Azure Analysis Services. In Azure SQL, they call them DTUs. A DTU is, I don't even remember what the acronym, Database Transaction Unit, maybe. Whatever it is, it's something that Microsoft has come up with that factors in disk performance and memory and processor, and they come up with this number. And from what you read is that, like, if you go and you read this, and then I actually experienced it. It was like I had a 10 DTU, most basic setup. I had a query that was taking 30 seconds. When I upped this sliding scale online, no downtime in the server, to 20 DTU, the same query took 15 seconds, right? Doubled the DTUs, cut the time in half. It's just a magic number that they've come up with. Yeah, it's a beautiful thing. And then, and they give you great visibility to what the cost is going to be. As you move up the slider, they give you a preview of what it would cost. I would say that like moving data size up barely changes cost, but your DTU does change the cost. All right. Yeah, so then like in this warehouse design, I call it a familiar pattern. In this design, you still have stage tables, right? So what stage tables are, and what's an important design consideration is when you're shaping your data in Databricks, you should have like an ERD built right before you start development. You should know what you're building to. Like you wouldn't build a house just like, oh, I built houses before, so I think I got to do a floor, and I think I got to put up some framing. Like, no, you do a ERD document, you model your data first on paper, and then when you build your Databricks notebooks, oh, I'm doing sales order. Okay, well, that Databricks notebook is going to write out to Data Lake a file that has these column names in it, right? So the pattern I use is I just put like ID after things that are going to be have surrogate keys eventually, right? So they might call it customer code in the source data, but you're going to call it customer ID, right? They might call it sales order number, but you'll call it sales order ID. And this is all when you're shaping your data in Data Lake, your column names. And then you'll have a SQL Server stage table. So I do like I keep everything in one database. I'll do like a stage schema. So that way I'll have like a sales order that's in the stage schema, and then I'll have a sales order that's in the DBO schema. These are my dimensions, right? And obviously, like I've got like a store procedure, post procedure that does a merge statement that's basically taking the stage table, joining in the dimension tables, and deriving what the surrogate keys are going to be. So that's kind of just a familiar pattern, but that kind of work still goes on. The difference is that your SQL Server stage table really has clean data. Like you don't even need to do any data validation or anything. All of that can be done in Databricks earlier on. You're really just moving data from that curated folder right into SQL tables that correspond. All right. And yeah, and just one last thing about that. So the advantages is that your data model is going to have unique constraints, so that you never end up with duplicate data. You're going to have foreign key constraints. I do a technique, by the way, with surrogate keys is I'll put if noted, let's say like in my stage table, customer ID was null. Well, when I go to look up my dimension value, obviously there's nothing to look up, right, for customer. So what I do is I'll store a -2 in customer key. If -2 represents them sending no data in. If they send data in, but it doesn't match anything in my dimension, I'll put a -1 there. Otherwise, I'll put whatever the customer key is. So I have like some meaning into my surrogate keys. Like the negative values represent certain data integrity thing or data issues. All right, analysis services, same kind of thing, little bit different. Analysis services I always look at as something that can be, if you deleted it, you can recreate it and rehydrate it very easily. So why I say that is something to know is, let's say you start out with just basic at $300, $319 a month. And you find that the performance is not acceptable and you need to go to standard. Well, you can't upgrade from basic to standard. You can go from B1 to B2. You can go from S0 up to, I think there's like 5 levels or 7 levels, I forget, of standard. But you can't just you just can't click a button and move between tiers like basic to standard. There used to be another one called developer. I think developer, basic, and standard. But in any case, you can always like blow away your analysis server, redeploy your code. Blow away the server, create the tier that you want, redeploy your code, and rehydrate the cube, and it's not that big a deal. Okay, so what I'm gonna say is just my personal opinion of why, like, given the choice, I always go with analysis services over Power BI models. And I know everyone's got like a different use case. I know there's companies that have hundreds and hundreds of Power BI models, and I'm talking like if I have like it's a greenfield project, nothing exists, ideally what would I do? And me personally, I prefer the development experience using tabular editor for development. If you're working with analysis services, tabular, and you're not using tabular editor, that may be the greatest takeaway from today's talk. This was like game changing for me. The short description of why it's so much better is tabular editor validates on save rather than validating at design time. If you've got a cube with hundreds and hundreds of measures, in Visual Studio, you go and you make one change to a measure, and then you got to sit and wait for the whole cube to validate. And then 40 seconds later, you realize, oh, that's not what I wanted to do. And you make a change, and then you watch this whole thing like very kludgely refresh. It's terrible. Tabular editor is beautiful. Like it's you can perform mass maintenance. Like you can search on all the fields of a certain data type, apply a certain formatting in a few clicks. It's got a great like right click on a table, refresh metadata to pull in new columns. It's like endless why it's so much better. But unfortunately, it doesn't work with Power BI files. It goes through phases where it does, and then it's not supported. I will say it's a third-party tool. It's not a Microsoft tool. I've been using it for several years now in production without any issues, but it has kind of mixed support with Power BI, and I wouldn't recommend using it to work with Power BI. So the development experience is better. Now, another development thing that I just find so cumbersome with large Power BI models is, you know, if you've got a lot of data in there, like publishing even a small change is like really tedious. Like, you know, you kind of have to do this hack to, you know, if your data is sourced from queries, maybe you have to change it so it does like a top 0, and so you have an empty model, and then you can upload the model and then refresh the model. But, you know, with Tabular Editor, it's like I can connect directly to the live model. I can add a measure, hit save, and it's saved in the model. And then I can do a save as and save my model.bim. And I've made a change like in seconds that gets really cumbersome when you're working with Power BI models to do, because you're working locally and then you have to develop, push it up to the cloud to be hosted. The whole experience for me is like really painful, and I don't prefer not to work that way. I really prefer Azure Analysis Services. And then there's the fine control you have over performance too, right? Like just like I mentioned with SQL Server, if you're experiencing a certain level of performance, but then you move up a tier by sliding a slider, yes, the cost goes up, but you know, I think that's really trivial with regard to how much headache a developer goes through and how expensive developers are. I think the price increases between tiers is really trivial. So yeah, those are my 3 reasons for analysis services. All right, so some analysis. This is like just how much time do we have? 8:30. Okay, so I kind of got to wrap up. I'm going to quickly go through these, and then I want to show you these last slides, which are on GitHub, which I think are probably just very valuable. All right, number 1, use Tabular Editor. Number 2, always source your data from SQL views. So in this architecture, right, we're going to end up with our model in tables, right? I recommend having a corresponding view for every dimension and every fact table. And the reason is you can easily add column logic without having to redesign your warehouse tables this way. Or worse, you don't want to build calculated columns in your model. There are some performance hits with that, right? It's always better to do the work as low as you can in the stack. Another recommendation is use legacy data connections. Legacy data connections, why would I do that? The new way is to use even Analysis Services in Visual Studio uses this like Power BI kind of connector for data, which in this architecture is irrelevant because we're not doing any transformations at this stage. We're doing our transformations in Databricks much earlier on. We're working with clean data in SQL Server, right? So legacy connection, and what that affords you is the ability to right-click on a table and do refresh metadata, and it brings in all the underlying changes. Fields that are going to be removed, fields that are going to be added, fields that are going to be changed, and you can put a checkbox next to each one and really have fine control over how your cube's going to change. I recommend hiding your surrogate keys. Just confuses users. They're useful only for model relationships. And this last one, this applies to Power BI development too. Always hide your aggregatable fields, okay? And what do I mean by that? Let's say you're like have a sales order table and there's a quantity field. Well, your gut feeling would be to drag quantity onto your reports and build all your visuals that way. I'm saying not to. I'm saying to hide quantity, create a measure called total quantity. Even if all it does is perform a sum of quantity now, at a later date, there'll be things that'll come up that you now have a hook into tweaking, right? Let's say that they want to do currency conversion or dynamic formatting, or they say, oh, I don't want to show any zeros on any of my reports when I drag this measure on. Even this last one, filtering out zeros, you don't think about it on day 1, 30 days from now you do. You can't just create a measure and have all the reports that are built take advantage of it. If all of the reports from day 1 are built using this measure called total quantity, you can change the underlying definition of that measure and enhance it however you want at a later date, and all your reports will still work. So it's just a good thing to do. All right, so we're at 8:30. We're supposed to stop. I'm going to do these few slides, which I'm calling bonus content. And this is of all the technologies we just mentioned, how to configure your GitHub to work. And I'll just fast forward to these slides. All right, so the assumption here is that you're familiar with GitHub already, right? And you're familiar with the concept of branches. No one's going to tell you to do this. I don't think you'll find an article that has something that looks like this. This is just from personal experience. What I found works really nicely. What we know for a fact. We know for a fact is Data Factory integrates with GitHub, and Data Factory allows you to specify what's called a root folder. It's optional. I'm saying do it. Don't make it optional. Like I'm saying specify. I like using this convention ADF. So I recommend having a dedicated branch for ADF. I call mine dev_ADF, and then within that branch to have a root folder called ADF. And I'll explain this concept of root folders in a sec. Databricks connects to GitHub as well. Now, I recommend having a dedicated branch for Databricks. And when you connect your notebooks, and you have to do it individually, prefix the connection with this subfolder, like /db, and then the path to your notebook. On your desktop, you'll never really have to work with these branches, right? These are like Databricks and Data Factory are cloud-based tools that talk to Git in the cloud, and you never really have to have those locally, right? What you do need to have locally are, and I'm assuming that these conventions are easy to understand, but AAS is Azure Analysis Services. You're going to be working with some local tool, whether it's Visual Studio or Tabular Editor, to develop cubes locally. AFN is one I just added. This is Azure Functions. Mentioned them earlier. You're going to write those in Visual Studio and deploy them to the cloud. So that's a local development. SQL. I mentioned doing all your SQL development in Visual Studio with data tools. That's local development. So you'll have a subfolder for that. And Power BI. One note about Power BI is do not store files that are over 10 megabytes in a Git repository. It will cause you major headaches. So PBI in this example is just because I'm in this architecture, my Power BI files are connected to data cubes, and therefore are very small. They have no data in them. They're just a few kilobytes. So why this subfolder technique? Well, the next step is production, right? And this is what I have for, I recommend checking in code frequently, right? Code that works to your branches, right? So if I'm working in SQL and I publish stuff to the development database, I'm going to commit that and sync up my dev branch. And I'm doing a lot of work committing and syncing in these dev branches. But eventually I'm going to do a deployment to production, right? And what that process involves merging. So I'm going to take my dev branch and merge it to my main branch. I'm going to take this branch, merge it to my main branch. I'm going to take this Data Factory branch and merge it in. And because we did the subfolder technique and they're all unique, now we'll have a main branch that will have subfolders for all those technologies. So this is a beautiful thing. Again, you won't kind of find it anywhere, but it might save you some serious headaches. Yeah, and this is just like a slide indicating what those meant. So analysis services, this is your model.bim. By the way, one other thing about Tabular Editor, model.bim is the only important file for a cube. Visual Studio will create hundreds and hundreds and hundreds of files. All of those files literally exist just to render that ugly user interface that they give you. That's it. There's nothing, all you need is model.bim. If someone gave me a model.bim file, I could open it up in Tabular Editor. I could publish the model to Azure. So anyway, that's what you store in here. Visual database projects, Power BIs, connected to cubes, Databricks notebook files, Data Factory components. Yep. So you may come back, revisit these slides. I think they're useful. And again, it's one of those things early on. So if I mentioned I started a new project, first I configured all my Azure resources. Second, I configured all the security between them. Third is I created my GitHub repository, all my branches, opened up all the tools, started connecting all my GitHub stuff. I mean, it's like this environment is like about 3 days of work to kind of set up so that it's working nicely. Future talks that I could do, a future talk could be on the whole GitHub deal. Future talk could be on just security across connecting all of these things together. Remains to be seen, but there's you know, and the other one could be just Databricks design patterns. So it remains to be seen. But all right, hopefully that was coherent, and hopefully Bob gives me a good good review.
Well, while you had lost your internet connection, his critique was that your presentation was far too short.
And then he never came back.
I'm still here, James. That was a great presentation.
Okay, all right, thank you.
But there are a few things I'd like to talk to you about. Maybe we could chat tomorrow.
Okay. Fair enough.